In this video, we'll take a look at another puzzle for which I encourage you to pause and think through this and see if you can determine what kind of Sphinx it is in terms of nature and form. Remember, nature, they can be logical or they can be deceptive. And then as far as form, could be winged or wingless. So another traveler meets a Sphinx, and the Sphinx says, "I am deceptive and winged." Okay, notice that we have the word "and" in here. So we're making two claims. We're making a first claim, or the Sphinx is making a first claim as well as a second claim. And in order for an "and" statement to be true, both 1, 2 must be true. Okay, so that would be assuming the outcome. The only way the outcome will be true is if both of those statements are true. If I am, so here's a truth table for this. Notice that now we need two columns because we have two statements, statement 1 and statement 2. So here are the different possibilities, and there's a couple of different ways you can list these truth tables out, but notice that I have true, false down the first column, and then true, true, false down the left column. And if you imagine you can sort of think about this as P could either be true or false, and then Q could either be true or false. And if P is false, then Q could still either be true or false. And this is where we get our first row, true, 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 false, false, true, false, false. You can see two possibilities which can get paired with two other possibilities has 4 total outcomes. And this just ensures that we cover each base. The only time an "and" statement is true is if both your statements are true, right? Because if I say I'm going to do both things, but I only do one, that means my "and" statement was false. In some contexts, we can call that a lie, but it, of course, isn't always deemed as a lie. Okay, this should actually be an L. Now, let's translate our statement into symbols. So I am deceptive and I am winged. Okay, the symbol that we use for that is this upside down V. And notice that this looks like the intersection operator. Remember, the intersection operator looks like this, and that operates on sets. So we can't actually recycle that symbol because our inputs are not sets, our inputs are statements. Okay, so how do we write this with an "and" notation using what we have? Well, I am deceptive. We have L and we have W. L is logical. So to be deceptive means you're not logical, and you are winged, which is given by statement W. Use the conjunction truth table to identify when a conjunction is true. Okay, so let's go ahead and write this in our context. Now, you notice that this is for P and Q, but we have a negation. So how do we build that? Well, here's how I recommend building it. Again, you can kind of go true, false, and then double the number of trues, double the number of falses. Okay, so the thing that I'm missing here is negation of L. And so I'm going to, before I build the fourth column, which will be not L and W, I'm going to build this helper column. And this helper column is just going to allow me to basically just look at these two columns instead of the first two columns, because I want not L. So if L is true, not L is false. So we'll have true, true would be false, false, and then false, false, the negation would be true and true. So now I just need to stare at my two columns here and here, because those are my two columns here and here. And the only time the "and" will be true is if both of those statements are true. And notice that only happens in the third row. And in the first, second, and fourth, at least one of those two columns is false. So don't think about not L as a more complex statement. Just think about this as one statement. It has its own truth values, and all you need to do is look at those truth values. So determine the Sphinx's nature and form. Well, you might already see that to call yourself deceptive would be a truth, right? That is, it would be a truth if you were indeed deceptive. So the only way that this entire thing can still be a lie, despite a deceptive Sphinx saying this, is for the second part to be false, right? So I am deceptive and winged. First of all, we know that a logical Sphinx would never say this, because a logical Sphinx is not deceptive, and if they said this, then this whole thing would be false. So we can actually go row by row and sort of analyze whether that outcome is possible. So here's how I want you to think about this. I want you to think about this as, suppose that this is said by what is in the first two columns. So that would be a logical winged Sphinx. Okay, well, if a logical winged Sphinx said this statement, it would be false. It would be a lie, right? But we know that a logical winged Sphinx would never lie, and therefore we can eliminate possibility 1. Story goes for row 2, because again, we have a logical wingless Sphinx telling a lie. And we cannot have that because logical Sphinxes always tell the truth. So we know this has to be a deceptive. But look at this. In the third row, we have a deceptive winged Sphinx, and the deceptive winged Sphinx is telling the truth. They are indeed deceptive and winged, and we know that a deceptive Sphinx would never tell the truth, and therefore it can't be deceptive and winged. And so we do have to analyze this final row because, it could be that this is not a Sphinx at all, not a valid one. So in the last row, we have a deceptive wingless Sphinx. So if a deceptive wingless Sphinx said, I am deceptive and winged, well, they would be telling a lie, right? Because though they are deceptive, they are not winged. And you have to be both in order to be telling the truth, deceptive and winged. But they are, deceptive and wingless. So this could actually be a truth. This would be a lie, but this is actually possible because it is allowed for a deceptive wingless Sphinx to call itself deceptive and winged because, hey, it's in its nature to lie, and that would be a lie for a deceptive wingless. So that's the nature of and. Both of those statements must be true in order for the outcome to be true. Otherwise, it's a falsity. Now, in the context of, in general, conjunctions, they don't have to call them lies and truths. It just makes sense in this context to say if the outcome of the statement is false, then that means it's a lie because we have liars and truth tellers. So in the next one, we'll take a look at some cross-statement reasoning. We'll go ahead and stop the video here.